Okay, I want to go over briefly how you create Miller indices of directions. And this is from your reading, the Ashby Guided Unit. And I want to point out that Miller indices of a direction, that's what we're working on, are always written in square brackets. Okay, so this is the way they're designated. And they're basically they are components of a vector. So you'll see them written in two ways. One with the square brackets as shown here, and then another with these these carets, these angled brackets. And these are when it's brackets like this, these are a direction. Excuse me, they're a family of directions. And then you could see that this family of directions contains all of these individual directions. And by the way, it also contains the reciprocals of those. It contains the 1 bar 0 0, the 0 1 0, excuse me, 1 bar 0, and then the reciprocal of that, that's 0 0 1 bar. So it's all permutations of these directions, and that's considered a family, that they're all basically rearrangements of these, and then also the opposite directions of those. Okay, let's look at how these directions were derived. And I'll just admit that these drawings aren't super great. So let's kind of start out, and we'll start with this one. This one's pretty obvious. So we have the XYZ axes, and the direction they're wanting to draw here is the 0 1 0 direction. And so what I do is I put the endpoint of the vector at the origin, and then I think I'll use another color. I'll use this green here. And then I go 0 in the x direction, 1 in the y direction, and 0 in the z direction. And I place my next endpoint. And then I draw a vector from the origin to the endpoint that I've identified. And you can see that that's this red line. Now they extend it beyond the unit cell, which is a little bit confusing in my opinion, as is this one right here. So let's do this one together. So the 0 1 1 vector, put the endpoint of the vector at the origin, or the originating point, the end of the, what is that, the tail of the vector. Okay, and then we need to go 0 in the x direction, 1 in the y direction. Okay, so 0, I'm starting here, 0 in the x direction, I do not move, 1 in the y direction, 1 in the z direction, and then I put the dot there. And my vector goes from the origin to this point right here. Now, what's a little tricky is when you have, in the direction, you have a 1 bar in the direction, or any number barred. So what that means is you basically have to move the origin. If this is a negative number, move it from the 0 0 0 point to in that particular direction. So I'm going to move this this origin +1. So I'm going to go +1. I'm going to start the vector here. Okay, so I don't think I can erase that other point right here. I'll use a different color. I'll start the vector here. And I'll go, okay, -1 in the x direction, -1 in the x direction. Oh, wait. Yeah, -1 in the x direction, 1 in the y direction, 1 in the y direction, 0 in the z direction, and there is my new endpoint. So my direction vector is from here to here. Now notice they drew that same vector, but they drew it up here. It's equivalent inside this unit cell. It's a little bit arbitrary, but you can see this direction is the same as this direction. You know, obviously, if we actually drew it out here, it'd be the same as that, you know, as long as it's parallel. So it depends on where you put the origin. And what I would recommend is placing the origin, if there's a negative number, placing it +1 in that direction. So let's do this one here. This one's kind of goofy. Now, when you have greater than 1 inside here, what I would recommend doing is pulling that number out, so that, you know, common factor out, and I would say 2, pull the 2 out, and do 1 bar, 1/2, 1 to get that same direction. So you're saying 2 times this direction. That's 2 is just the magnitude of the vector. So this would be half the size of the vector, but the direction would be the same. Okay, so we need to go, since we have a one bar in this x place right here, the x, y, z, I would add 1. So I would start at 0, 0, 0. I would add 1. So now here's my new origin. I'll use a different color. I'll use green. Here's my new origin. And I'll start from there. So I'll go -1 in the x direction. -1 in the x direction. I'll do 1/2 in the y direction. 1/2. That will put me right here. Then I go 1 in the z direction. That will put me right here. So the direction vector would be from here to here. See, they draw the head outside there, and that makes it confusing in my opinion. Anyway, I hope this helps. Okay, let's go over the procedure here. So let's say the first thing that you want to do is draw the XYZ axes. The second thing is to determine the origin as the tail of your vector, the direction vector. Okay, and in this case, if there is a negative number in the direction vector, move the origin in the positive direction for that axis. And then the next thing you want to do is determine the endpoint. And you want to do this, this would actually require you to remove a common factor if any of the indices are larger than 1. Okay, determine that you have now the tail of the vector, the endpoint of the vector, and then last thing, draw the vector.